and this mountain is only 3,554 feet tall. Why can we see it?
So this is part 2 of explaining it to King Sleeper. We found Bald Mountain at 4,000 feet tall, and right here is Bald Mountain in Georgia. If we scroll out, we can see that Lookout Mountain is right here. We've gathered that it's 41 miles away. We use Google Earth and see that the elevation of 7 states is about 1,600 feet, a little more. We'll plug those numbers into the calculator. Say 42 miles, 1,600 feet. We should be able to see the horizon at 49 miles with nothing obscured. It's almost like we can see the entire mountain that you're pointing out. This took me about 5 minutes to figure out. I would recommend everybody do their own research before posting nonsense. Now, I'd love to believe in flat Earth, so somebody give me some proof that can't be debunked so easily. What's going on, everyone? So I wasn't going to do a debunk on this video, but this woman keeps going into TikTok lives and saying that she made a 200-mile observation and then flat earthers are just eating it up without double checking anything. Now, maybe she's mistaken and not purposely lying, but when people try to walk her through the details, she seems to get emotional, start calling people disingenuous, and refuses to even look at the information because it'll just shatter her flat earth belief. And because of that attitude, I'm going to break it down. So here's her video. She gave us the GPS coordinates of this, the location of this, but she does this, zooms in, pans around, freeze frames here, and this is the key point. We have this ridge here, so we're going to draw a line of sight. And then she looks around. And I am going to pause it in just a second because what she does is she pans left and then pans right. So here we go. It's a little fuzzy, but we have this defined like ridge line here. Then there's a defined ridge line here, and then another one way back here. Now she did this one a while ago, and then she posted this picture saying 200 miles, and in the Flat Earth Live she says 200 miles. Now she gave us the location, Tavaputs, whatever the heck it is, ranch, in the sticks of Utah, middle of nowhere, Utah. Kind of nice because we can grab because she gave that, we can grab the coordinates, which I just clicked a random spot and grabbed them. Now on Google Earth, what I did was mapped out her field of view left and right. So we know that she's looking through this range here, and we'll revisit this in a sec. Now we took the GPS coordinates and plugged them into PeakFinder, and this is pretty much her field of view. It's a little off, but that's about her field of view right there that she showed. And she panned around and everything. And here's where it is interesting. If we look at her video, we can see the ridge here, and then she zooms in just over this ridge and then pans around a little, and we can see what matches her video. So this is that first mountain line. This is that second mountain line. And this one way back here is the farthest line that she claimed is 200 miles. And when we click it, oh man, it's 67 miles away. And what's fun about PeakFinder is we can get the GPS coordinates. So we'll grab those, plugged it into Google Earth, but we're going to do this to save time. Look at the elevation profile. It is smashed here because I'm trying to make this thing full screen. So she's standing at 9,050 feet high, looking across all of this way below her at some mountains that are 6,400 feet high. So she's not even looking into Colorado. She's looking right into the border of Utah. But anyways, yes, this is what she's seeing. She's seeing 67-mile away mountains. We can plug it into Walter Bisland's. I put 68 miles here and see that, oh man, she should see that mountain range. So yes, she's seeing 67, 68 miles. She's telling people 200 miles. This is why you should do your own research and not just blindly believe what people on the internet keep telling you to believe. So here's the takeaway for everybody, not just flat earthers or science deniers, absolutely everyone. Verify things. This woman confidently repeats 200-mile observation to hundreds, probably tens of people really, who are just accepting it without checking anything. But once you actually look at the maps, check the line of sight, check the elevation, the truth is simple. She's not saying 200 miles. She's saying 67, 68 miles. Pretty much exactly what the globe predicts. Interesting that. So did Chewy prove flat Earth? I'm making a video about this because Chewy doesn't seem to want to have a genuine conversation about his observation. He took this killer picture of Toronto's skyline from a place called the Lakeview in Hamilton, Ontario. So let's plug in the numbers and test it beyond the I can see it test. From Chewy's vantage point to the CN Tower is 32.5 miles or 52.3 kilometers.
In his photo, he's standing back from the water line and the camera's about head height, so we're going to say a 6-foot observer height. And with a quick search, we can see CN Tower is 1,815 feet. Plugging these numbers into the advanced Earth curve calculator, we got 6-foot observer, 32.5 mile distance, 1,800-foot target, and we're going to do 0 refraction. That's interesting. So at a max hidden, because of 0 refraction, we only have 580 feet of hidden height. So Chewy's observation does show more than just the CN Tower, so let's see how many buildings are above even 600 feet. We've got the CN Tower here that says NA, so we're not going to use that one. Wow, so not including the CN Tower, there's 35 buildings above 600 feet tall. So I'm not going to count how many buildings are in Chewy's photo because that's more work than any flat earthers ever put in. But I will say it actually looks like there might be a little less than 35 buildings. So Chewy, I do want to say thank you again for proving globe. Your observation matches what we'd expect pretty much dead on. And this is why numbers matter a lot more than the I think I see too far test. So if you, Chewy, or any flat earthers think I did something wrong here, let's talk about it. I would love to help you guys prove flat earth with data that backs it. But so far, all the data points to globe.
So all of us over on TikTok know Flat Truth's famous Davis-Besse observation. He shows this picture from Michigan, looking across Lake Erie to the Davis-Besse nuclear power station, and acts like it's some kind of unbeatable flat earth proof. The weird part is, his own observation, half of that cooling tower is missing. And it's flat earth proof? What we're seeing here is half of a cooling tower, and a little bit of the reactor shield building off to the left there. So let's point out a few problems. First, he runs around a lot and says 27 miles, 27 miles. And then when you ask him where he was, he just says this neighborhood, Woodland Beach. So my guess is he's probably in this park. He's probably not in somebody's random backyard. We're gonna say at this park, and the farthest point he could be at this park, which is 26.06 miles to the cooling tower. So he already starts off by inflating it by a mile. The cooling tower itself is 493 feet tall. It's not some dinky little building. And that building we're seeing a little bit of is 296 feet tall. I know he keeps saying 200 for some reason, but it's 296 feet tall. Now, I'm not going to say he's lying, but I will say that he's had this observation for 2 years, so it's weird that he's still getting incorrect distances and heights. But that's beside the point. With this picture, since we're seeing the smaller building, let's test it. So he doesn't give his exact location, so we can't get his exact height, but I know he's standing in that park somewhere, so we're going to go 10 feet because he's standing above the lake. I'm pretty sure when you're playing in that park, you're not standing with your feet in the water. Target distance, 26.1 miles, like reality states, not his random 27 miles that he claims. And the target size, 296 feet. In reality. And this article actually has it in the article itself. And because we're looking across the lake, we're going to do standard refraction. It is a real thing that a lot of flat earthers seem to fight against, even though there's countless studies of it, and they refuse to go study it. With all that being said, that little tiny building, we should still see 30 feet of it. I can't tell you how many feet we are seeing of it, but I'm definitely telling you, we should be seeing it according to the globe. But we'll do something better. We'll add in the cooling tower. So there we go. We've got the 493-foot cooling tower, the 296-foot reactor housing building, and would you look at that? Those kind of look like his picture. And here's the funny thing. If we were to put this on a flat earth, we should be seeing the entire buildings, period. That's the end of this stupid argument. And the weirdest thing is this argument. So there's 264 feet hidden, and a flat earther will look at this and say that this little black line here is 264 feet of things compressed to near zero. I hate to break it to you, people that look at this picture and think this is somehow flat earth proof. It matches a globe, and you cannot compress 260 feet of something into a singularity, like flat seems to think exists. Thank you for coming to my TED Talk on how Flat Truth's observation matches a globe prediction pretty damn spot on. And thank you, Flat Truth, for proving the globe. And if this video made it where you are now coping hard and denying reality because you feel like a failure, ask your community about Copium. Copium is a once-daily emotional stabilizer designed to help you dismiss inconvenient truths and deny reality. Copium works by reducing exposure to accountability, suppressing critical thinking, and reinforcing biases confirmed by other dumb people online. With Copium, you can continue believing what internet memes tell you you must believe, even when evidence says otherwise.
What's going on, everyone? So Gene the Gullible has something new, and I found out yesterday that he took it from apparently their new Flat Earth leader, Angels of Lies, who seems to be doing better work than any of the other Flat Earthers. But as always, they're sharing a picture of someone else's work, not their own, and they're calling it Flat Earth proof. And once again, it only works if you completely misunderstand simple geometry. So Gene and Angels are running around showing this photo of Monviso, taken from just east of Pisa, just under 300 kilometers away. So here's the uncropped picture so you can get the full idea. This is the land, and then water running up, and then the mountain back here, 296 kilometers away. This took him 4 years to do and dozens of failed attempts. So if we look back here, we are lucky enough to get named peaks, Monviso, and down here is
Punta Gestaldi. So Monviso has an elevation of 12,600 feet, and that lower peak has an elevation of 10,545 feet. Okay, so I've got Photoshop open. We cropped in the image a little bit. If you look here, we drew those two lines, 12,602 feet, 10,545 feet. So that's a difference of 2,050 feet. So we added this little green line. We know this is 2,050 feet. So if we add a bunch of these green lines, that should be 6.1 of these green lines from the top of the mountain to the base of the mountain. We're showing 4.5 of these missing, plus the 0.1 down here, behind this hard horizon line. It's not haze, it's not cloud, it's simple geometry. So here's the problem for flat Earth. If we look at the hard horizon line that we can see running across here, especially if we zoom this picture out like this, we can see that it cuts off the mountain across the whole way here. So there's a massive amount of this mountain that appears to be missing. On a flat surface, distant mountains like this would shrink linearly, like the law of perspective demands. We should see the entire mountain, just smaller. It wouldn't get sliced on a flat surface. So we've got PeakFinder open. We're going to find where he was on the map. So he says east of Pisa, and he has actually taken pictures from up here before. So my guess is he's somewhere around here. So we'll just go as close to 400 meters as we can, grab those coordinates, plug them in and head there. And then let's find, here we go. So Monviso. Okay, so PeakFinder says that we should see Monviso. His picture is showing that we see Monviso. So wouldn't you know, it matches almost perfectly. It's weird how this globe-based model of PeakFinder matches reality pretty damn close. But here's the thing I love about PeakFinder is we can jump really high. Look at how much mountain is missing behind globe math horizon. There's a hill and then a valley and then a lot of mountain. And it's weird that Earth-curvature predicts this. So flat Earth has no mechanism to explain selective mountain slicing. This photo isn't flat Earth proof. It's literally globe geometry, and it works exactly like predicted and expected. So welcome to the globe and how to do proper research. And what's going on, everyone? So this is Chewy's new observation, and it's a really good observation again. He's showing Toronto from near Hutch's on the beach, and he's saying that this here is the Sky Dome. Oh, and he turns the camera. We'll go back. So he's saying that white thing is the Sky Dome there, and he does a zoom in where he changes it. So there we go. Saying that that's the Sky Dome. So let's check it out. Okay, so this is about Chewy's observation angle. I'm going to zoom in a little bit so we can see some more. The hard part is this, like, because Earth's curved, it appears that we have a higher elevation when we try to line up these buildings. But anyways, we'll go with roughly what it is. You can see a little gap here in his video. You can see that the Sky Dome is directly underneath the tower and this building. But for some reason, his observation is showing the big reflection over in this area. So I'm going to try it with something else. So this here is a 3D model of Toronto that we can see. And we know that this about here is the angle that he sees. We can see this building. We can make out this defined building as well as these two with the little gap in between. Again, the Sky Dome's here, but for some reason, his observation, we're seeing like this bright reflection over here. So I was thinking, well, wonder what building that could be. I honestly think it's this building, which is the EY Tower, and it's got these mirrors that are angled from the sun to bounce light pretty perfectly back at him. I hate to point it out. I hate to call Chewy out again. I love that he's out there making observations, but realistically, let's use some dignity. That light reflection does not line up with the Sky Dome, period. Chewy, you can refute that all you want, but when we look at any model of Toronto and the angle you looked at it, it doesn't line up. So I hope we can figure out what it was, but that light's not the Sky Dome. Sorry.
So I love this guy. He cracks me up, and he was so close.
Another globe-tard here, people. He claims he's addressed certain topics, like why you can see Chicago from across Lake Michigan when it should be 10 miles of curve, on why you can see across 500 miles of water the other city when it should be 10 miles down.
So yeah, after measuring Chicago across Lake Michigan, he said 500 miles, and no matter how you measure it, you're not hitting 500 miles. So I did kind of this 300 range. I mean, it's pretty arbitrary once you get that far. So we plugged in the 297, and yeah, hidden under 10 miles of curve. So the problem is all the videos that we see are filmed from Indiana Dunes National Park. So from Indiana Dunes National Park to Chicago, it's about 30 miles. We plug that into our curvature calculator, and 486 feet are hidden. So that's less than half, about half of some of these skyscrapers, or there's a ton taller than that. So there are a ton of skyscrapers that you would see at least 100 or more feet of still. So I want to challenge somebody to this. From Chicago to Sawyer, Michigan is 50 miles. At 50 miles, it's 1,400 feet of curvature, right? So let's see if someone can hide all of the towers from that distance, or show me 10 towers from that distance. And that would be pretty definitive proof that there isn't a curve across Lake Michigan. And
Came across this video earlier today trying to show a flat Earth from Niagara to Toronto. So you can see we have Niagara Falls, Toronto here. I think they are at this park, just because like the park benches. So we'll put a pin there and then come over to Toronto, loop right by the CN Tower. So 30 miles. We have a topography map. Niagara coast is about 277 feet. Toronto, 266 feet. And then, so the tallest buildings are, the CN Tower is 1,800, 1,000, 970, 900, 892, and so on. When we plug into the distance calculator, 486 feet should be hidden, so really only half of the tallest buildings. So I feel like the proof presented here isn't really proof of a flat Earth, because we can still see some buildings. Now if it was 3 times the distance and we could see the buildings, then we would have an argument.
This is in Tennessee. It's called C7 States. Okay, South Carolina, 80 miles this direction, okay? And this mountain right here is called Sassafras Mountain. It's 100 miles away, roughly.
I'll make your argument better. It's actually 145 miles away.
Every 100 miles, you should have 6,600 feet of curvature.
You are really close about that.
And this mountain is only 3,554 feet tall.
That is a fact. So now I'll explain. I found this picture, which is about the same as the one you used. There's the same mountain range way back there. On here, on Google Earth, there's 7 states. I found the same mountain range way off, so I had scrolled over there, which I won't do here, and found these mountains. They're 41 miles away. With Google Maps, I found one of them's called Bald Mountain. So we looked it up, and Bald Mountain has an elevation of 4,000 feet. So how can you see a mountain that's 3,500 feet behind a mountain that's 4,000 feet? Explain that. We're going to do another one. Here's one of Pookie's observations. He's seeing a wind turbine, 6-foot observer. It's 14 miles away to Delaware. Let's check that out. So it looks like that windmill to the hub is 256 feet. And when the blades are fully extended, they go up to 400 feet. So it's really weird that he feels like he shouldn't be able to see that on a globe Earth. But let's do the math. Okay, so using the numbers Pookie gave us, which we all know he's extremely accurate at measurements, it looks like only 63 feet of this thing should be hidden. And doing a little bit more than the I see it test, we can see that it's sitting on ground about 14 feet above sea level. So I know what people might be thinking. Oh, this still shouldn't look like that. So we can model it. So I did this, and there's how much should be hidden, our 64 feet. And this is what the windmill is. There's our 256-foot hub. These are our blades that run 140 feet. So yeah, it's kind of weird how closely this matches globe prediction and Pookie's observation. Thank you for coming to my TED Talk on how Pookie needs to learn to do observations better.